Hello everyone. I was going to do this topic as a filler at the next meeting. However, I've got engrossed with it, so I've decided to make a video to set you a problem and just to explain why we've called this Physics for Old People. I've not done it to remind us that we're all getting on a bit, but I've done it because there is an approach to physics where you go from some very general principles and can solve some really quite specific problems. And usually when people learn physics, they go from the particular to the general. So I'm trying to go in the opposite direction to see how far we can get. So I've enjoyed doing this, but let's see how it goes. Okay, I'm going to do a bit of really basic physics. Those that remember O levels, this used to figure in the O level physics syllabus. What we have is a coil, solenoid if you like. A current passes round the solenoid. In this case it's going in an anti-clockwise direction. The current induces a magnetic field in the material. The polarity of the substance is the north to the left and the south is to the right. If we reverse the current, I think we're all going to guess what it is that's going to happen. The polarity of the magnet's going to be reversed. Well, that's about it. That's all the physics that I think we need to remember in order to carry on with this presentation. Okay, I'm now going to talk about Ronnie O'Sullivan, probably the greatest snooker player in the world. But if you want to argue with that, you probably wouldn't argue with the fact that he's the greatest left-handed, right-handed player that we've ever seen. Let's just run through these sets of photographs. If we look at the top two, one of them is Ronnie in the real world, the other one is Ronnie reflected in a mirror, and you've guessed it's the one on the left that is the one in the mirror. How do we know this? It's because the image is laterally inverted. There's some things that are not symmetric on reflection that we've put there, like the letter E. Letter A does actually reflect, but it's the entire word needs to be reflect as well for us not to be able to tell. Looking at the second set of images, a little more tricky. You could figure out which one's which if you knew which hand Ronnie wore his watch on, or perhaps if you knew which side he parted his hair. Again, left and right is very much a human concept, and we have visual clues as to what's left and what's right. Now, if we look at the snooker table at the bottom, there are two shots. One is the mirror image of the other shot. Now, I'm going to propose to you something that was believed right up until 1956. All famous physicists would have said this is quite an unremarkable statement. But the statement I'm going to make is that if the trajectory followed by the snooker ball follows physical laws, then both shots are equally possible. That is to say, you can't determine whether you're seeing an image in the real world or its mirror reflection. Where did that law came from? Well, people doing physics, philosophers, just made it up, but it seemed highly plausible because they would argue, well, there's nothing different between left and right, and if you want to argue in spiritual terms, God's not left-handed or he's not right-handed. So it all follows that if it follows natural laws, you don't put any left-right bias on the structure, then you won't be able to tell whether it's a real shot or it's one in a mirror. Okay, here's the homework. If we pass a current through the coil, we get a magnetic field pointing with a north pole at the top and a south pole at the bottom. Right in the middle of the coil we put some radioactive stuff. Don't think we need to know what it is. What the radioactive stuff does, it it does transformations, but during that process it spits some electrons out. They're usually called beta particles. I think that's about all we need to know. Just to say, the nuclei that are undergoing the radioactive change can actually feel a magnetic field. So here's the problem. If we count the electrons at the top, we get X%. And if we count the electrons at the bottom, we get 100 minus X%, because those two things added together is 100%. So if we reverse the current, we'd reverse the magnetic field, and we'd have 100 minus X at the top counter and X at the bottom. So here's the homework. Incidentally, if you were a physics undergraduate, by this time you'd be reaching for the textbooks and you'd be writing equations all over the place. I think I've told you enough to work out what X is without recourse to the textbooks. But let's see if you can. And more importantly, once you have worked out what X is, if you've worked out what X is, just Y. Thank you, and I will actually give the answer to this at our next meeting.